Okay, welcome back to this algebra review, and we're going to pick up on the topic of factoring. So, as you'll see into this course, factoring, we're going to do a lot of factoring, especially when it comes to things like limits and other types of concepts where we have to simplify. And so, one of the most used tools in order of getting to where we need to go is factoring. So, really, there's really two ways to factor. One is part A, right? Where if you see there's no like number here, right? It's just X. So that's one way to factor. And if you look at part B, this is a little different because there is a number here. There's a six. So these would be, it's kind of the same process, but they'll be treated a little differently in terms of simplifying it. But let's go ahead and check it out and see what happens. So if we have x squared plus 6x plus 8, we want to factor this, right? That means we want to get it to look like something like this, right? X and X, right? Into single X terms. There's really a, what I've been taught and what I do is really sort of a diamond method where I have this kind of this cross right here, and I'm going to take this 8 and put it up here, and I'm going to take this 6 and put it down here. Okay. So what I want to do is find two numbers that add up to 8. I'm sorry, that multiply to 8 and add up to 6 simultaneously. Okay. So it's sort of this game you kind of play where you want to find two numbers that satisfy this at the same time. So I know that 2 and 4, if I multiply those together, I'll get 8. And if I add them together, I'll get 6. So that is how we factor this one. So what it factors into is just an expression, 6, and you take your numbers that you just found, x plus 2 and x plus 4, and you're done. And that's it. So, you might have a different way of doing it that you were taught, but for me, what I always do is just kind of this cross. I take my number there, I take the middle one here, and you just got to find two numbers that add up and multiply to those numbers. Okay, so let's check out part B now. So part B is a little different now, right? So it's a little different because we have the 6 here. So we're going to kind of treat it this first part like we did that we just did right now. Take the cross diamond, and instead of just this last number here, it's going to be 6 times 8, right? This first term times this term. Okay, so what that would be is negative 48. Okay, and this part stays the same, where it's just the middle term on the bottom. Okay, so a little different, right? Because we had to multiply these together, but same thing goes. We want to find two numbers that multiply to this top number, negative 48, and add to the bottom number, negative 8. So it's a little weird because they're both negative numbers, but just think along those lines still. So I know two numbers that multiply to negative 48 are 12 and 4. And so I know that negative 12 times 4 would be negative 48. And if you add those together, you will get negative 8. Okay, so it definitely comes with practice, right? You might not get it off the top of your head, but it's really the way to go about it. It's just find these two numbers. Okay, so it'll just take a little practice to get used to if you're not familiar with it already. Okay, so here's where it gets a little different than part A is that we're going to keep this the same, 6x squared. But now we're going to change this into negative 12x plus 4x minus 8. We're changing this 8x into these two middle terms here. Okay. So now we're going to do something called grouping. Let me rewrite this a little bit. Factoring by grouping. Okay. So this is why we we're kind of building up to this. But here's where we have to factor by grouping. So what we're going to do is factor out something out of these two terms here. What do they have in common? Well, they have 6 in common. 6 goes into 12, and they have an x in common. So I'm going to factor out a 6x. So what I'm left with is x minus 2. If I take out a 6x, right? And I'm going to do the same thing over here. 4x minus 8. What do they have in common? They only have a 4 in common. So I'm going to factor out a 4. And what I'm left with is x minus 2. Okay, so see how whatever's in the parentheses is the same exact thing? Well, that's exactly what we want. We want to get the same thing in the parentheses. Okay, so what that means is one of your expressions will be x minus 2. Okay. And then your other expression, right? So see how in part A we have two expressions like this. Your other expression would be the stuff you factored out. So it would be 6x plus 4. And that would be your answer. Okay. So that is how you factor by grouping. Okay. So a little more involved, right? It's not as straightforward as this one, right? This one's way more easier. This one has a couple more elaborate steps to do, but it's really the same process over and over again. Just kind of replacing the middle term with the terms you found here, factor by grouping, and then get your final solution. Okay, so take some practice to do, but with anything with more practice, you get better at it. Okay, so kind of a leading question for this last part here is like, can you solve for x? What do I mean by that? Well, say for example, this first one here, I set it equal to 0. Can we solve for x? Oops, sorry, let me scroll up a bit. Can we solve for x? And the answer is yes. So there's a property, right, that we can do. Maybe you remember this. This is about like finding roots and stuff like that. But what we can do is separate them. You'd have x plus 2 equals 0 or x plus 4 equals 0. And then you just solve for x in both situations. So you'll get x equals negative 2 and x equals negative 4. So that's how we would solve for x. Okay. Likewise, on the other side, we would have 6x plus 4, x minus 2 equals 0. Same thing, 6x plus 4, x minus 2, oops. Okay, and you would get 6x equals negative 4. So x equals negative 4 over 6. And that simplifies to x equals negative 2/3, right? And then you just get x equals 2 over here. Okay, so that's how you would solve for x for these. And we're definitely going to be seeing things like this where maybe you're finding some type of x-intercept or root, and you need to solve for x, and you need to factor out a function and get to this process. Okay, so that's how you would deal with that. So that is factoring. If this was still confusing, there's definitely tons of videos on YouTube for help. Um, you know, just take some practice, though, is what I would say. Okay, so let's move on to our next topic, which is just exponents, right? So, um, learning how to deal with exponents, simplify them, manipulate them is like going to be really important for us, right? And when we do something called derivatives later on in the coming weeks, it's going to be really important that we know how to handle them, right? So, what do I mean by handle them? Let's check out a few examples, right? So, if we have something like x to the negative 2, right? This is weird, like x to the negative 2, but what I want to do is make this negative 2 positive, right? This exponent positive. So what I can do is actually just bring down this expression. And what I would get is 1 over x squared. So you see how this was you could think about this as like over 1. Let me clean this up a bit. This was like over 1. And if I brought this down, it will just become 1 over x squared. And now it's a positive exponent. Okay, so I moved it down. Now it's a positive exponent. Likewise, if I had 1 over x to negative 5 on the bottom, and I wanted to make that negative 5 positive, I would just bring it up. And what this becomes is 1 over, sorry, would just be x to the 5th. Okay, so that's how I make a negative exponent positive. I could bring it up, I could bring it down. It's the same exact thing. It's just sometimes algebraically we have to deal with it positive. Okay. Now let's check out part C. We have 2x to the 6. Well, what if I want to make this negative now? Well, if I want to make it negative, I'll just consider it like over 1. Well, same thing. I'll just bring this thing down. And what I would get is just 2 over x to the negative 6. Okay, so if I want to make it negative, that's what I would do. Likewise, if I want to make part D, right, 5 over x to the 8th, if I want to make that x to the 8th negative, I'll bring it up. And I will get 5x to the negative 8. Okay, so that's making them negative. So what about a square root though? We'll be seeing something like this. Well, a square root, that could be changed to x to the 1/2. Okay, if you think about it, let me zoom in a bit. But this is like saying x to the 1 and it's a squared root. So this becomes really a fraction exponent. That goes there and that goes there. Okay. And if you see a square root, that's exactly what it means. You put that in your calculator, it'll mean the same exact thing. All right. So now let's check out this example here. 1 over the cube root of x. Same thing. I want to change this into a fraction exponent. So what this becomes is just 1 over x to the 1/3. That 3 goes on the bottom, and this 1 goes to the top. Okay. And same, maybe what if I want to move this to the numerator? Well, I could just rewrite it as x to the negative 1/3, right? If I want to move this up. Okay, so that is just playing around with some exponential terms, okay? So now what if I want to simplify exponents, right? What if I have an exponent on the top and one on the bottom? How do I simplify that, right? Well, it's really just adding or subtracting, right? That's really all it is adding and subtracting these exponents. You see how this was on the bottom, right? This x to the eighth. Well, if I brought it up to the top, it's -8, right? Well, that's kind of the same way of thinking. So if I look at part A, it's x to the seventh over x to the third. What that really is just x to the seventh minus 3, which is just x to the fourth. Okay, that's pretty much it. So likewise, if I have x to the third over x to the seventh, it's really just x to the 3 minus 7, x to the negative fourth, and then say I want to make this a positive exponent, well, then I'll just bring it down to the bottom, x to the fourth. Just bring it down. All right, and then that's how you would simplify that one. Part C, you have x to the ninth over x to the ninth. Kind of a trick one. What does that equal? Well, that just equals 1. All right. If it's just like x squared over x squared, that'll be 1 as well. Okay. Say if I had like 2x squared over x squared, well, these would cancel out, but you'd still be left with 2. Just a little side example. Okay. So let's look at part D now. Part D is x over square root of x. So like we just did in the previous set of examples, that square root of x is really x to the 1/2. So it would be x over x to the 1/2. And this will just be x to the, really, we don't write the 1, but there's really just like an invisible 1 right there. So it would be like 1 minus 1/2, right? So that would just be x to the 1/2, which is really just square root of x. Okay. So this part E, we have another radical, right? We have the fourth root of x, right? So remember, we kind of have like this 1 right here. And let's just go ahead and change this into a fraction exponent. So what that really becomes is just x to the 1/4, okay, over x squared. But same thing, it will just be x to the 1/4 minus 2. And, you know, 1/4 minus 2, you'd have to common denominator times 4 over 4. This would be 1/4 minus 8 over 4, which is 7/4. So I'll write like side over here. So what this becomes is just x to the 7/4. Sorry, -7/4. Okay, and once again, if we want to make this positive, we will just bring it down. So it'll just be 1 over x to the 7/4. And if you want to make this a radical, if you want to be fancy, it will just be like the fourth, sorry, it will just be 1 over the fourth root of x to the 7th. Okay, so that is how we handle or simplifying these exponent expressions, right? We'll be seeing some of this in calculus, right? So try to get a little bit of a handle on it, okay? So lastly is a concept that we don't see too often. We won't see too often in this class, maybe just maybe just in finding limits. You'll see it in a couple weeks, but um, something called rationalizing a numerator or denominator could be either or, but it's just a situation where if you have nothing else, if you have like a radical expression like you have here, square root of x plus 2, and there's really no other way to simplify it, well, you'd have to rationalize the numerator, and there's no other type of algebra that would fix this situation. So what do I mean by rationalize it? So you might have forgotten this from, it's a little niche. You might have forgotten it from your algebra, but what you would do here, if I want to rationalize this, if I want to simplify this, what I need to do is multiply the top and bottom by the same thing, x squared plus 2, or I'm gonna use a different color. I'm going to multiply it by the same radical expression, but I need to have a different sign. So plus, you see how this is minus 3? I need to have plus 3. Okay, and I need to do that to the top and bottom. And this is the process of rationalizing this numerator. I'm multiplying it by the opposite sign. So what this becomes is, so the key to this is you don't want to multiply out the denominator. So you want to keep these two separate. You want to have square root of x plus 2 plus 3. You want to keep that separate. Over um, you know, x plus 2 minus 3 times square root of x plus 2 plus 3. Okay, so let's go off to the side and work this out a bit. So square root of x plus 2 minus 3 times square root of x plus 2 plus 3. So we're going to simplify this a bit before we write everything up there. So square root of x plus 2 times square root of x plus 2. They're square roots, so you're really just squaring it. So what that becomes is just x plus 2. Okay. So, or you know what? Kind of, it's like saying this, x plus 2 squared. Okay. And then x squared of x plus 2 times 3. So it'll be plus 3 root x plus 2. And then negative 3 times square root of x plus 2. And then negative 3 times 3, which is just negative 9. Okay, so if you notice, these terms cancel out, the 3 and the negative 3. And so what we're left with, oh, sorry, and this square root of 2 and that square root cancel out. So what we're left with is x plus 2 minus 9, right? maybe I went a little too fast, but square root of anything squared will just be whatever that is, right? So the square root and the squared are canceled out. But so what you're left with is x plus 2 minus 9, which is just x minus 7. Okay, so that's what we're left with. So let's kind of come back here. So that means I'm left with x minus 7 over x minus 7 times square root of x plus 2 plus 3. And so what you're left with is x minus 7 over x minus 7 times square root of x plus 2 plus 3. And so this works out really well. And the x minus 7s just cancel out. So what you're left with is 1 over square root of x plus 2 plus 3. And that is how you rationalize a numerator. Okay. So this something like this will work out really well if like we're trying to find a limit or something along those lines. Okay, so that's as much algebra as I'd like to go over for this algebra review. And see you next time. Thank you.